Okay, anyways, guys. So most of them came from page 165 or that area. Remember, there's two general types of projectile problems: fired horizontally and fired at angles. The first one we had, number 51. I like this one. You accidentally throw your car keys horizontally. That happens to everybody, right? By accident. In the end, this one's asking for how far from the base of the cliff, which is delta x. They land, which you should get around 29 meters. Any questions on that one? Just to remember, probably like the most important, at least starting point for a projectile is fired horizontally, is as soon as you know it's fired horizontally, you know a given just from that. What is it? Yeah. Vy initial 0. Don't forget that, otherwise that will seem unsolvable. And then the majority of the horizontal fired ones we've run into, most of the time they don't ask you to find what, but you need to. Yes, time. Number 52, another horizontal fired one in part A. We are asked to find the time, and that's about a half a second, 0.5 seconds. And in part B, you should get about 0.8 meters per second. Anybody need to see that one? Part B, how fast was the car going on the table? That would be Vx. You want to see that part? Yeah. All right, so you okay with part A? Yeah, I got it. All right, so we'll do 52B here. So what we're looking for is Vx. We need to use the t found in part A. So if we transfer the t, if you were okay with that, the t from part A is 0.5 seconds, right? And in the picture, you could see that it gives us delta x, right? 0.4 meters. So all Vx is, when you rearrange the only equation we have, and remember the reason why on the x-axis in all projectiles we have just that one little equation is how is it traveling on this axis? Constant, right? As long as we're neglecting air resistance. That allows us essentially to be equal to use V equals D over T. And that's 0.4 divided by 0.5. Oh, there you go. So, you good? Yeah, sorry. So 0.8 meters per second. Any other questions on that one? All right, 53, again, another horizontal one. Most of these were. There was a few angled ones thrown in there. How far away we're looking for, and that refers to delta x in this one, 3.2 meters. Or something close to that. We're good on 53? 55 was next, right? Yeah. All right. Still another one that's horizontal. You were asked two things in this one. First, how high the platform is, and that would be 33 meters. And then how far from the edge, that would be delta x, 7.3 meters. Now just on the first part, the nature of solving is you find out how far the projectile fell, right? So directly your answer comes out as what kind of answer? Negative, right? Representative fell down that far. But just ask the question using a little common sense. Since it said how high the platform is, obviously we wouldn't put negative 33 high, right? We know that's how far it fell, so that must mean the platform is positive 33, right? Can you skip over that? Yeah, sure. Okay, you took a running leap off a high diving platform. You were running at 2.8 meters per second and hit the water 2.6 seconds later. So if I'm running off a diving platform straight off, that makes that, we'll make our x and y column of givens. That must mean that Vx is 2.8, right? And if I run right off of it, like how this suggests, that means this person's a horizontal projectile, so Vy is 0. like always on this axis. We're in free fall. And we are given the time. We hit the water 2.6 seconds later. So the t, remember, could go either way, right? I could use it in x or y column. So I might as well just lift it. But not a lot of problems gave us time. That just makes it even really a step shorter than many. We don't have to find it. How high was the platform? So that would be y, right? Height, y-axis. So first thing asked is to find that, delta y. Using what we know right there, that would lead us to equation 2. Since equation 2, Vyi is 0 in it, we could just cut out that middle term, and it's just 1/2 gt squared, right? Don't even need to rearrange it. We could pop right in. And this is how I mean your answer should come out a negative number because delta y technically represents the change in y displacement for the projectile itself. So how far it's going to fall. So you should get somewhere close to, what did I say, was negative 33 or something close to that. But to answer the question in terms of how it asked it, that must mean the platform was 33 meters high. So technically you should drop the negative to just answer what it's really getting at there, right? We okay with that part? And then the delta x is just this equation, Vx times t, and we got both of those, right? So we could just take the 2.8 times the 2.6, and you should get out something like 7.3 meters. We all okay with that one? Okay, moving along. 56 was next. This is one at an angle, and it's pretty much asking the typical things that we were asked in any other projectile fired at angle problem we did, like in examples or the handful of practice ones we had. So in 56A, you should get about 31 meters for the max height, but let's just review a couple important things about that. What's the easiest way, because there are multiple ways, but what's the easiest way to find the max height? Set what equal to 0? Yes. Vy final. All right. Don't forget also, this is where the other two equations with sine and cosine come into play. Because when it tells us stuff like 49 meters per second at 30 degrees, right? That's the velocity at the angle. That is not a helpful number until we use those two sine and cosine formulas to break it up into Vx and Vyi. Then we could plug those into any of these other formulas like we were using in any other projectile problem. So A should be about 31 meters, and the how far away refers to delta x, also known as range. You should get around 210, maybe a little bit. What's the exact non-sig answer for that? Was it 210? Okay. For some reason, I thought it was a little far away on that one, unless you can think of another one. All right, so 31 meters and about 210 meters. Anybody need to see that one?
Yeah, just that 31 meters. I thought that you said we could use that going up and down.
Okay, but here's the problem. Think about what it's asking with what you just said there. It's asking for the maximum height, right? For part A?
Yeah.
Right? So we cannot, part A isn't over here. Part A, the projectile's here. Clearly, delta y can't be 0 here, because delta y is the vertical height, right? So the only time, just watch, you're partially right with what you said. Once it gets to here, we could say, if that helps me, delta y equals 0. But here, that's what we need to solve for, right? If it says max height, height is delta y, right? So that's the unknown. Does that make sense? I'll do it out completely if you need to, yeah. Okay, we'll go through all of it. No, that wouldn't make any sense. If it couldn't be at the top if delta y is 0. Delta y is how far it's off the ground.
Would it help if you solve it that way? Like the way to find out?
There's no situation where you could call delta y 0 other than at the very end. If it's something in question at the very end. Because delta y is the vertical displacement. And displacement's only 0 when you come back to where you started. I started fired from there and I ended vertically from the same spot, right? Not horizontally, but vertically. Does that make sense? Okay, so like any angle problem though, we're going to find Vx by using Vi cosine theta. I'm just going to plug right into it. That's going to be 49 cosine 30. Make sure your calculator tomorrow is in degree mode. Whatever one you're using on your Chromebook or if you have your own. And this would be 49 sine 30. And that breaks up that velocity into these two components like we drew them in the notes. Here's where Vx occurs and Vy initial. It's like we're looking at both of these things separately, right? So, somebody, just to speed up, somebody who got this problem right, tell me what Vx is. Yes?
42 meters per second.
Exactly 42? And what about Vy initial?
24.5 meters per second.
24.5. Everybody okay with that? Got that? Okay. So again, for part A, then we're looking at the max height. So they were finding this at this position, and at that position we said Vy final is what? 0. You got to remember that. If you don't, you're probably not going to get this part right. Okay? Because right there is its peak, so it has to stop for a moment before it comes back down. And with that, we could say G is negative 9.8, and Vyi we found right here, right? So all that is Y information, and we solve for delta Y at that position, and that is the max height. And we could use equation 2, no, not 2, we don't have 2, sorry. We could use equation 3 to find delta Y. So that would be Vy final squared equals Vy initial squared plus 2G delta Y. Vy final 0, so therefore delta Y is equal to negative Vyi squared over 2G. Plug into that, and let's say that was again 24.5. Uh, 2 times negative 9.8. And that's how we should get something close to 31 meters. Are you okay with that part? Alright, moving along to part B. Let me just go back to the original rough diagram up here. So in part B, we want to know how far, the target is at the height from which the arrow was shot. So that means it's telling you basically it came back down vertically to where it was started, right? And that's where we said, now we could say that's true at that position, right? And using that, we're going to find delta x, how far it went horizontally. All right. Now, this is the point, though, where we should realize very soon that since delta x equals Vx times t, and that's the only equation we have with delta x in it, right? Now, we did find Vx earlier, but we obviously don't have what right now? Time. So we're going to go back to our y information, but at this position, okay? So we have to put a hold on that for a moment. We could still use the fact that Vy initial is 24.5, along with G equals negative 9.8. We can't say Vy final is 0 here. That was only at that middle peak position, right? But we can say delta Y equals 0, like we pointed out above. And with that, that will all be enough to help me find T. And remember, be careful with the algebra here for this. We use equation 2, delta Y equals Vyi t plus 1/2 gt squared. Since this is 0, that makes the whole left side of the equation 0 since it's the only thing over there, right? What was the next step we did algebraically that you would have to do to solve this in the easiest way possible? Yes? Right, divide out a t. 0 divided by anything 0. This t and this t will cancel. And the second power will come down to cancel with that t down there to be a first power t. And that leaves me with just to clean it up a little bit here. After I cancel out all those t's, I just have this, right? And now I could isolate that one single t right there by subtracting over Vyi, multiplying by 2 because of the 1/2, and dividing by g. So t will equal something that looks like that. do that correctly. That would be 49. Let's try it. 49 divided by 9.8 negatives cancel, which they should. That comes out as exactly 5 seconds. Oh, that's not the final answer, sorry. Now we could use that 5 seconds back over in here and multiply it by the Vx. What was the Vx? What was it? 42 times 5. And that gets exactly 210 meters, right? So that's a pretty typical, what we are normally asked, projectile angle problem, right? So far, those haven't gotten too much different of the ones we showed originally. You need to know how to find max height, you need to know how to find the range or delta x, and you probably need to know how to find t in most of them. All right, moving along to number 58. This was basically another horizontally fired one. Watch, because there was a conversion. There was 125 kilometers per hour had to be converted. The 58A is about 14.3 seconds, and B is about 497 meters. Any questions on that one? Okay, 59. Another horizontal one. 6.5 meters per second. That's very close to it. You might need to see that one. Okay. That, I believe, is delta x, isn't it? Vx, that's Vx. Yeah. We'll do it real quick. Alright. In 59, it said diver dived from a cliff that's 61 meters high. If the rocks below the cliff extend outward 23 meters, what's the minimum horizontal velocity? So it says horizontal right there. That's all we care about. The diver must have to clear the rocks. So here's the cliff. Here's some rocks down here. So we need to use, that 23 meters is the delta x. So we're going to use that because that's what we need to clear, right? And the diver is just going to go off horizontally, try to clear that. So the Vx of the diver is what's in question. So let's see our other givens here. The cliff is 61 meters high, right? That's my delta y, and he's going to fall down that much, so I should make it negative. And since it's a horizontal projectile problem, we could say right at the moment everything starts, so that's 0, right? So we don't know time. Like most horizontal problems, we got to find time, right? With whatever we can. We also know that g equals negative 9.8 meters per second squared. So that with that and that is enough to give me, using y equations, time. All right. So again, we've done this several times, so I'm going to just go to the rearranged one. Solving for equation 2 for time yields 2 times delta y over g, the square root of it. Okay. And this is the same equation we had to use the last couple of days for time in air, right? When we did the lab. So that's 2 times negative 61 divided by negative 9.8. Yeah, if we run that right. Somebody got this right, tell me the answer to your time here. 3.5. And now we could use that to find Vx. The equation, the given equation that you'll be given tomorrow looks like this, right? So when we solve for Vx, we got to divide the t over. And that makes it 23 from the given up there, divided by 3.5. And that's how we should get about 6.6. Is that what I said? 6.5. Around there. 6.5, 6.6 is fine because we didn't use sig figs. It actually comes out 6.57 in just the rounding we did. That's fine. That's close enough either way without using sig figs. Okay? Meters per second. Are we okay on that one? Okay, and the final one came off page 867. number 4. Like I said, I'm going to throw out part B. There's a couple minutes I'll tell you more specifically why. But part A, now there still was a little twist to this one that was different. But I think it was, if you read it carefully, it was pretty easy to figure out. I'll draw a diagram for this one so we're all on the same page. So we're shooting a basketball. But when you shoot a basketball especially, it's not ground level, right? So the person's holding the ball. And I'm just going to draw, here's the floor, right? Here's the court. I'm just going to draw a dotted line, horizontal line, for the level of the ball, right? From where it was shot. And it tells us that this level from here to here is how much in this problem? Number 4 on page 867. What's that? No, I'm asking you, what is the height the ball is above the floor? 1.5 meters. It tells us that in some way, shape, or form. But we won't really care about that till kind of the very end. All right? We're going to solve this just like a normal projectile at an angle problem. We're going to treat this dashed line as if it were the floor for just a moment, and then bring in the 1.5 is the easiest way to think about this one. So this is going to be shot at an angle. And it's going to go, and it's going to reach some peak and drop down in, right? The question is about its peak, its max height, right? Which the equations themselves assume that the thing is shot from like a floor, right? So this is going to be, we got to find this delta y, but that won't officially be its max height till we add what to it? 1.5, all right? Since we're 1.5 off the floor. Does that make sense to everybody? All right? So as long as you do that, it's really not that different of a problem, is it? One little extra step you had to get from that. Now, it told us we shot, I think the angle was 68 degrees, and it goes with a VI equal to 10 meters per second. And actually, for what part A asks, we only need VYI. You might have found VX, but you would have found in part A it's not necessary. So 10 times the sine of 68 gives me VY initial. I this out earlier. That should be about 9.27 meters per second. Using that, along with, like always, free fall, right? And at the peak, one more time, what do we put? All right. So use that, and that to solve for delta y. And again, that's equation 3. Vys squared equals Vyi squared plus 2g delta y. With that being 0 means, again, delta y is negative Vyi squared over 2g. So that's going to be negative times 9.27 squared divided by 2 times negative 9.8. And we will get 4.39 meters. Now, in most problems where the thing was told it was shot from that ground level, that would be our final answer, right? This is almost our final answer, but what did we say we got to add to it? 1.5. Because if we want its max height, we would have to assume that means above the floor, right? That's why they told us the floor was 1.5 meters. So when you total that, the correct answer is 5.89 meters. So that was a little twist that if we read carefully, you should have been able to get. Well, the angle did matter, because look, didn't we have to use it in this step? Finding this. Right? The angle affects what your VYI is. So if, like, let's say you are the same person or a different person that shoots this thing still with 10 meters per second, but at an angle of 40 degrees. That's a much different max height, right? So absolutely the angle mattered because it was right part of that calculation, okay? You good? Yeah, cosine finds you Vx, which you didn't need for part A. Now, I'm not, like I said, I'm not going to go fully through part B because I'm throwing it out. But in part B, it says if the basket rim height is 3.05 meters, how far above the rim is the ball? And even when I first read that, when I saw my problems, I always just double check the answer too, just to make sure I didn't make any mistake. And to me, reading that, I assumed it meant from where we just found it, right? Which if you took it that way, like I did at first, you would just subtract 3.05 off of 5.89, right? But I looked in the back, and you would get, if you do that, you get 3, no, I'm lying. I don't know, I did it out somewhere. You would get 1 point something, right? Or 2.84. Oh yeah, I was looking at the wrong thing. So, but when I look at the answer in the back, the answer is 0.73 meters. And the only thing else they could mean is when the ball actually got to horizontally, and it never stated that. And I wouldn't expect anybody to assume that. I just think it was a poorly written problem. All right, that's where the 6 meters would have came in. In part A, you didn't need it. It was not necessary. It did say we were 6 meters away from the hoop, but for finding that maximum height, you're clearly not to the hoop yet. You're before it, so the 6 meters was irrelevant for part A. But again, I just didn't like that they weren't clear on that, so I'm just don't even worry about it. I wouldn't put one that was that vague on a test or anything. All right, but that's it. Any general questions about projectiles? Yes. 53. Yeah, let me put that there. 53. You're looking for delta x. It looks like 3.2 meters. You good on that one? Yep. Anything else, guys? Like I said, quiz will start tomorrow. I know 18 minutes is not a lot of time, so we'll start tomorrow. You guys aren't here Monday, right?
Yeah.
So you could finish it Tuesday. All right, you shouldn't need a whole period Tuesday to finish, but I'll give you what you need. I'm done today unless there's questions.